Hello students, welcome to the course Digital Speech Processing. So in this video I am going to explain the first classroom discussion topic, that is Introduction to the Speech Processing. So you'll be aware, after completing this video, you'll be aware what is a speech signal, how we can generate a speech signal, and what are the various kind of applications in speech processing. That also you'll be seeing here. Alright, so this is the lecture learning outcomes. So on completion of this lecture, you'll be able to understand the speech signal and you'll be able to list the various applications in the speech processing. So coming to the introduction of the speech signal. So as we already know, the main purpose of the speech is the communication, the way how we are transforming our information to convey the same information to the other persons. Okay. So that is the main motto or the purpose of the speech is the communication. And one more point you need to understand here is that it is very highly non-stationary signal. Okay, it is not the stationary signal, it is non-stationary signal. So in speech communication system, the speech signal is transmitted, stored and processed in many ways. So the way we already know about the digital signal processing, okay, so in the signal processing also the transmission of the signal can be possible and also storing of the signal can be possible. So likewise here also, so the signal is the speech signal, that is only the difference. Okay, the way how we are transmitting, storing and the processing the content of the message signal, everything is the same. So in general we will be seeing the two major concerns in any system. The first important concern is that preservation of the message content in the speech signal. That is very important. So in the speech signal, what is the message that is available? So that we need to preserve first. And the second important thing is that representation of the speech signal in a form which is convenient for the transmission or storage or in any form that is flexible so that modifications may be made to the speech signal without seriously degrading the message. So these are the two important major concerns we look into the designing of any system when it comes to the signal as a speech. Okay. So information content of the speech signal may be extracted by the human listeners or automatically by machine. So the imagine a situation where the two persons are communicating. Okay. So the first person is the source, or let us assume like that. The other person who is listening, the speech whatever you are conveying is the second person, the destination part. Okay, and in the destination we can also put a machine. Okay, so automatically that will be grasped whatever the information that they are going to be conveying. Okay, and in the design and the implementation of these representation, the methods of the signal processing play a fundamental role. So signal processing, which involves first obtaining the representation of the signal based on a given model, and then the application of some other higher level transformation in order to put the signal into a more convenient form. Okay. So now let us look into the flow, the signal processing flow, how it could be. So this is the signal processing hierarchy. So first we can consider the information source, and the second is a measurement of the observation. Third one, representation of a signal. Fourth, transformation of the signal. The last one, the extraction and the utilization of the information. So in our speech signal processing, so this information source is nothing but the speech which are provided by the human. Okay, the speech which are provided by the human we are taking as an information source. And now coming to the measurement of the observation, we need to observe the parameters, characteristics of a speech. Okay, whether it is speech is voice or unvoiced, whether it is mixing of the both voice and unvoiced. So that we can see here. And the third, that is the signal representation. When it comes to the signal representation, it is again divided into two important categories. The first one is a waveform representation and the second one is a parametric representation. Okay, so these are the two important categories that may be possible in signal representation. Okay, and after that the transformation of the signal. Okay, so these two blocks comes under the signal processing. So how we are processing the signal, that is very important fundamental role that we are going to be seeing according to this flowchart. And the last, of course, extraction and the utilization of the information, what that is conveying, the human, whatever the human that is conveying the information that we are going to be extracting. at the last. So this is completely the structure of the signal processing. But whereas when it comes to the speech signal processing, the information source may be the human message. And the representation of the speech signal, I clearly mentioned in the previous slide. So we'll be having the two important categories, that is waveform representation and then parametric. But mostly we'll be interested towards the parametric representation. Here again, we'll be having the excitation parameter and then vocal tract parameter. So these are the two important parameters we need to evaluate. Okay, so that we can see the parametric representation that we can see in the further classes. So this is the structure of the representation of the speech signal. The two important, that is waveform and then parametric. Now coming to the applications. So this is the speech communication application we'll be having. The wide various application that you will be seeing here, the digital transmission and storage. So when it comes to digital transmission and storage, we'll be having the vocoders. That is the first the thing that we have understood. That is voice coders, we can also call. So that can be first identified by Homer in the early 1930s. Okay, voice coders. And the main advantage of the voice coders or vocoders is that the bandwidth efficient module that is a very bandwidth efficient. Okay, so bandwidth conservation can be possible with the help of that vocoders. And coming to the speech synthesis, it is also by other kind of an application we can see. And speaker verification and identification is also we can see. Okay, so speaker verification, nothing but we need to identify who is speaking what. Okay, so that we can see identification. And the speech recognition. So what is the speech given by the speaker? Okay, so that we need to see, that is the speech to text we can call speech recognition. And then aids to the handicapped. So the handicapped people, also the deaf people, we are going to be using one machine, right? In that machine we will be designing one model. Okay, so that can be help for the people who are handicapped. Okay, and the last, enhancement of the signal quality, that also can be possible. Okay, so how we can enhance speech quality. Okay, and at the same time how we need to reduce the noise component in the speech that is consistent. Okay, that is also very important consideration we can see. So overall, what you need to understand here in this slide is that the speech communication application will be having a wide variety of application. Okay, and so much of research which is going on how to reduce the noise component. And we also know the noise cannot be completely eliminated. And by using some of the digital techniques, the models, some part of the noise can be eliminated. So that is what actually the research is going to be happening around the world. So this kind of application that we are going to be witnessing. Thank you, students. Thank you very much for watching this video.